So let's go ahead and start solving this problem. So we perform the experiment, we've gathered our data. Now what do you do with this? So I know that I added enough of my known, which was a base, to neutralize the acid, but how do I actually know the concentration of that acid? All right, so we could use stoichiometry. We're just going to do everything with strong acids and strong bases, so I'm going to teach you an even more straightforward formula, which is take the number of hydrogens in the acid, multiplied by the molarity of the acid and the volume of the acid used, set that all equal to the number of hydroxides in the base, times the molarity of the base, times the volume of the base. So let's start looking at what we worked with here. So our acid, I can double check, was HCl. Our base was NaOH. And our acid, we used 10 mLs of it. So HCl has 1 hydrogen. The molarity of the acid is the concentration of the acid. This is actually what we don't know. This would be like your X, right? Like this is your unknown variable. The volume of the acid, we used 10 milliliters. Okay, and then we're going to set this equal to what we know about the base. The base was NaOH. Its concentration per the bottle was 0.5 molar. And we performed the experiment to figure out how much was used. So NaOH has 1 hydroxide group. The molarity of the base was 0.5 molar. And the volume is what we figured out experimentally, right? That's why we put it in the burette and we measured the final and the end values. So 17.76 mLs. And of course, I didn't leave myself room. There we go. 17.76 mLs. So now all we need to do is solve for that unknown. Okay, so 1 times Ma times 10, so that's going to be, wrong pen. So that will be the molarity of the acid times 10 milliliters is equal to 1 times 0.5 times 17.76. So that's going to come out to 8.88 molarity times milliliters. And to get our unknown by itself, right, we want to divide this side by 10 mLs. And we do the same to the other side. So the molarity of our acid, so we take 8.88, divide that by 10, is going to give us 0.888. And take a look. Milliliters cancel out. You are left with molarity. And that should make sense because we're solving for the molarity or the concentration of the acid. The last thing we need to deal with are sig figs. So the 10 has 3, the 0.50 is 2, this is 4. The lowest we have is 2. Now, if you're asking like, wait, number of hydrogen, that's 1, or hydrogen and hydroxide, that's 1. Well, these are counted values, right? Like there's no discrepancy. If I see HCl, there's only 1 hydrogen. So those don't count towards sig figs because it's not a measured value. So again, back to here, 3, 2, 4, the lowest amount is 2. So this would become 0.89 molar HCl. That is the concentration of our unknown acid. So hopefully this helped you out a little bit. I'll have another page of some examples in another video. So feel free to check that out if you need more help with this.